Hello everyone. In this session I am going to discuss pre-engineered buildings. Let us see what do you mean by pre-engineered buildings, what are all the components of pre-engineered building and the difference between pre-engineered building and conventional building, and also what are all the advantages of these pre-engineered buildings. During 1960, the standardized engineering designs for buildings has been first marketed as pre-engineered buildings. So, in 1960, the standardized engineering designs for buildings are first marketed as these pre-engineered buildings. So, its potential has been felt during recent years. Then what do you mean by pre-engineered buildings? So, the pre-engineered buildings are the buildings which are manufactured at factory and assembled at site. So, pre-engineered building is a technology where the entire designing is done at the factory and the building components are brought to the site, and then at the site these building components are jointed or fitted by using a bolted connection, and also in the site these building components are raised by using cranes. So, these pre-engineered buildings are usually the steel structures. So, the pre-engineered buildings are mainly the steel structures. So, the built up sections and angle sections are fabricated at the factory and then it is transported to the site, and at the site these built up sections are assembled by using a bolted connections. So, built up sections are the sections which are formed by existing sections. So, example for this built up section is built up I sections, that is built up I beams are used, and also the angle section. So, the angle section is a L-shaped steel structure, either it may be a equal angle or unequal angle. Both these built up sections and also angle sections are fabricated at the factories. So, these pre-engineered buildings gain popularity mainly because of its benefits. So, what are all the benefits of pre-engineered building means? It is fast to construct. Since it is a steel structure, it is fast to construct and it is economical, and also these building components are dismantled and it can be reusable. So, based on these benefits, the pre-engineered building gains popularity nowadays. Due to increase in trends in construction, these pre-engineered buildings are used in construction of industrial and commercial buildings such as factory, then warehouses. Warehouses are nothing but the storerooms, godowns, and workshops, and supermarkets, and shopping malls, and stadiums, showrooms, and metro stations, etc. So, these are all some of the applications where the pre-engineered buildings are built or adopted. That is factories, warehouses, workshops, supermarket, shopping malls, and stadiums, showrooms, metro station, etc. So, let us see one of the first pre-engineered building and also the largest pre-engineered building in India. So, the Reliance Corporate Park. So, the Reliance Corporate Park in Mumbai. So, the Reliance Corporate Park, which is located in Mumbai, it is one of the India's first and largest completely pre-engineered commercial office building. So, it has an area about 50,000 meter square. So, it has an area about 50,000 meter square. So, this is the first and largest pre-engineered building in India. So, this is about the brief history of pre-engineered building. Let us see what are all the components of these pre-engineered buildings. Major components of pre-engineered buildings. So, PEB is nothing but pre-engineered buildings. So, the pre-engineered buildings mainly consist of these major components. So, the major components of pre-engineered buildings are mainly classified into 4 types, that is primary components, secondary components, wall and roof panels, and also some other accessories. So, the primary components mainly consist of main frame. So, the primary components mainly consist of main frame. So, these main frame basically consist of rigid steel frame, rigid steel frame. So, let us observe in the figure, it shows the complete steel frame of the pre-engineered building. So, these main frame consist of trusses, columns, and also castellated beam and rafters. So, it consists of trusses, columns, then castellated beams and rafters. So, the main frame consists of trusses, columns, castellated beams and also rafters. So, truss is an assemblage of members. So, the members are joined by using nodes in order to form a rigid structure. Let us observe in the figure, it shows the structure of truss, how exactly the truss will be, and also the columns. So, column is an vertical structural member which transfer the vertical load to the foundation. Then castellated beam. So, the castellated beams are the built up I sections. Here the I section used will be I beam. So, the I beam is subjected to longitudinal cut portion along its web. So, longitudinal cut will be done in an web portion of the I beam. So, let us consider this is an I beam, this is web portion, this is flange, this is also flange. So, the built up sections are formed by an existing section. So, already existing sections are there From that the built up sections are formed. So the built up I sections I showed in the figure, these built up I section consist of web portion and also two flange portion. So let us consider it is a flange portion of the beam, this horizontal portion is a beam, this is web, this is a column or end support which acts as flange portion to that beam, another flange will be in the other side, so it will form an I beam. So along these horizontal portion, along these web portion, the beam will be cutted with a specific pattern. Such type of beams are called as castellated beams. Let us observe in the figure, it shows the cutted portion and also the castellated beam, which consists of cutted portion with a specific pattern. Then coming to the rafters. So the rafters are provided to give support to the roofs. All the loads of these structural members are transferred to the base through end wall frames. All the loads of the structural members are transferred to the base through end wall frames. These end wall frames are connected by using a wind bracings and also connecting bolts, that is anchor bolts. So wind bracing means these are all the structural members which are provided to the walls. So inner portion of the wall, that is inside the wall from bottom to the top, so in an diagonal position, in order to prevent the wall from falling and also twisting, that is called as wind bracings. So these wind bracings and connecting bolts are provided to the end wall frames. This is about the primary components of the pre-engineered building. Let us come to the secondary components. Secondary components of pre-engineered building. So the secondary components of pre-engineered buildings are cold formed structures, that is available in different shapes, that are C and Z sections, which are commonly known as purlins. So these secondary components are cold formed structures which are available in C and Z shape, which are commonly known as purlins. Commonly known as purlins. So these purlins are provided to the roofs, and also the C purlins and Z purlins are there. So both C and Z purlins are used. So the C purlins are provided for the openings such as doors, windows and also ventilators. Then Z purlins. So C purlins are provided for door, window and ventilators. So Z purlins are provided as roof purlins and also end wall purlins. So these Z purlins are provided as roof purlins and side wall purlins. So the purlins which are provided at the side walls are called as guts. The purlins which are provided at the side walls are called as guts. Then these purlins, for more structural stability of the steel buildings, these purlins transfer the load from one frame to another frame, and also these purlins are more resistant to corrosion, lightweight and can be easily mounted. So these purlins are available in different lengths and also thickness. So this is about the purlin. Let us observe in the figure, it shows the both roof purlins and also the side wall purlins, how exactly the purlins are provided in a steel building as a component. So the another component is eave struts. The eave struts are provided at the intersection of the walls and also the roofs. Let us observe in the figure, it shows the eave struts. Then cable bracings. So the cable bracings are connected to the column in order to ensure the stability of the building under different forces. Let us observe in the figure, it shows how the cable bracings are connected to the columns. So the another component is cleats. So the cleats are the structural members which is a steel plate structure which are used to combine two members together, which are used to join or combine the two members together. So let us observe in the figure, the cleat is a plate like structure, there will be a hole in between, so there will be a holes. So the two different members are connected by using these cleat plates by providing a bolted connections. So this is about the cleat. So the another component is flange angles. So the flange angles are used to connect the beam rafter to the purlins and also column to the side wall purlins. So let us observe in the figure, it shows the flange angles. So this is about the secondary components of the pre-engineered building. Wall and roof panels. So the another component of pre-engineered building is the wall and roof panels. So the wall and roof panels are provided in a pre-engineered buildings. So the roof panels or the roofing is done by using a sheets. So the roofing is done by using a sheets. So the sheets which are used in the construction of pre-engineered building are base metal of galvalume coated or cold rolled steel. So the sheet which is used in the construction of pre-engineered building are base metal of either galvalume coated steel or cold rolled steel. Then the wall panels which are used in the pre-engineered buildings are curtain walls. So these curtain walls are made up of glass or metallic plate, and also the wall is done by using a sandwich panels. So one is the wall is done by using a curtain walls. Curtain walls are the exterior walls which are made up of glass or metallic plate, and also sandwich panel. So these sandwich panels are made in 3 layers which is exactly as similar to the sandwich. So the sandwich panels in wall are made in 3 layers, that is one non-aluminum layer is placed in between two aluminum sheets. So, the one non-aluminum layer is placed in between two aluminum sheets. These are all aluminum sheets. This is non-aluminum layer. So, the sandwich panel of wall is done by using 3 layers, that is one non-aluminum layer is placed in between two aluminum sheet. So, this is how the walls and roofs are made in pre-engineered building. So, the other accessories pre-engineered building are the other accessories of the pre-engineered building are, so these accessories are non-structural components of the pre-engineered building, which consist of bolts, screws and washers, skylight, then turbo ventilators, then door and window. So, these are all the non-structural components of the pre-engineered building, which consist of bolts, screws and washers, and also skylight and also turbo ventilators, then doors and windows. The door used in pre-engineered buildings are roll-up doors, and also the window louvers also used in the pre-engineered buildings. So, these are all the components which makes the complete pre-engineered building structure. Let us see what is the difference between these pre-engineered building and also the conventional building. Why we are using these pre-engineered building? So, the difference between pre-engineered building and conventional building. So, let us difference some of the properties in both pre-engineered and conventional building. So, the first difference or the first property is design. So, the pre-engineered buildings are quick and efficient. So, these conventional buildings are slow and tedious. So, the pre-engineered buildings are designed very quickly and also efficiently, because all the components are manufactured at factory. We can easily design very quickly and efficiently. But the conventional building, the design process of the conventional building will take some time. So, it is slow process and also tedious. It takes some time. It may delay for designing the pre-engineered building. It requires some time compared to the pre-engineered building. Then another property is foundation. So, the pre-engineered building requires simple foundation, but the conventional building requires extensive, large and heavy foundation. Since all the components, all the structural components of the pre-engineered buildings are lightweight, so it requires simple foundation. But the conventional building has heavier components, heavier structural members, beams, columns, slabs, which are made up of concrete. So, it is heavier. So, it requires extensive, large and heavy foundation in order to resist the weight of the above superstructure. So, the foundation will be simple for pre-engineered building, but it is extensive, large and heavy for the conventional building. So, the other property is duration of construction. So, the another property is duration of construction. So, the pre-engineered buildings can be constructed within 6 to 8 weeks, but the conventional building takes 6 to 25 weeks. So, the pre-engineered buildings, since all the components are manufactured at the factory, there is no necessary of casting and curing at the site. So, that is why it will take 6 to 8 weeks, but the conventional buildings are casted or fabricated at the site only. So, that it will require 20 to 26 weeks because it requires the casting and also curing period. So, the another property of difference is that is seismic resistance. So, the seismic resistance will be more here, this will be less. Since the lighter frames in a pre-engineered building, since pre-engineered buildings consist of lighter frames, all the lighter frames will have more resistance to the seismic forces. But in conventional building, the heavier and rigid frames offers less resistance to the seismic forces. Another property is future expansion. So, the future expansion is simple, easy and quick, but it costs more and tedious. Any expansion in the future is required in pre-engineered building, it will be simple, easy and quick. But the conventional building, if the future expansion is required, it costs more. Since it is a concrete structure, it costs more and also it is a tedious process, it requires time delay. Then another property is erection time and cost. So, the erection time for erection of pre-engineered building. So, the pre-engineered building requires less equipments for the erection. So, it will be completed in a couple of weeks. So, the erection cost will also less. But in conventional building, heavier equipments are required. So, more equipments are required in conventional buildings for erecting, and also it can be completed in 2 to 3 months, since casting and curing period are mandatory in conventional buildings. It can be cost more than the pre-engineered building. That is, conventional building, the erection cost will be 20% more than the pre-engineered building. So, the erection time and cost less, but in conventional building the erection time and cost will be more, that is 20%. 20% more than the pre-engineered building. So, the another property of difference is overall cost. So the overall cost of pre-engineered building will be 30% less than conventional buildings. So the overall cost will be more in conventional building. So the overall cost, the material cost, construction cost and also maintenance cost will be more in conventional building since it is a concrete structure. But in pre-engineered building, so the overall cost, the material cost and also the maintenance cost, since we are providing high quality paints in a steel structures, it will more durable and it will have less maintenance. So that's why pre-engineered building will have overall cost will be 30% less than the conventional building. It will be more in conventional building. Then another property is structural weight. So the structural weight of the pre-engineered building, since the components, since the building components or the structural members are lighter weight. So what are all the structural members, beams, columns which we are used in pre-engineered buildings are lighter weight, but what are all the components or structural members which are used in conventional building, that is beams and columns, slabs are heavier weight because it will be the concrete structure. So the structural weight of the pre-engineered building will be 30% less than the conventional building, but the structural weight or the structural member, so the weight of the structural member in conventional building will be heavier. So the structural members are heavier in conventional building. So these are all the main differences of conventional building and also the pre-engineered building. So let us see what are all the advantages of using these pre-engineered buildings rather than the conventional buildings. So these pre-engineered buildings will have some of the advantages over conventional buildings, that is since all the components of the pre-engineered buildings are manufactured at the factory, it will reduce the construction time. Since all the components are manufactured at the factory, it will reduce the construction time. Reduce the construction time, since it does not require any casting and curing, so it will reduce the casting and curing time. So it will reduce overall construction time of the pre-engineered building. Since we were using pre-engineered building, it will reduce the overall construction time because it eliminates the casting and also the curing time. Since all the components are manufactured at the factory, only thing is we will brought to the site and then it will be fitted. So less cost. So here we are avoiding the concrete structure. Just by using the steel structure, it will reduce the cost of the construction and also cost of the material. And it will be used for larger span. So the pre-engineered buildings are used for larger span So the clear span having 80 meter, there we can also use the pre-engineered building. So the pre-engineered buildings are used for larger span construction. So the another advantage is quality control. Since all the components, all the structural members are manufactured at factory in a controlled condition, so the quality of the material or the quality of the components will be assured. It will have a good quality. Then another advantage of pre-engineered building is flexible to expansion. So the another advantage of these pre-engineered building are flexible to expansion. If any expansion is necessary in future, in pre-engineered buildings, the expansion will be done very easily and also quickly by using additional base along the span. So we can easily expand the building. So we can easily expand the pre-engineered building by using additional base. So the expansion process will be flexible. We can easily expand the building in pre-engineered buildings. It is one of the advantage of using pre-engineered building. So the another advantage of these pre-engineered buildings are architectural versatility. So these pre-engineered buildings will have very good architectural versatility, and also these pre-engineered buildings will have energy efficient walls and roofs. Energy efficient walls and roofs. So these pre-engineered buildings will consist of energy efficient walls and roofs, and also the last advantage of these pre-engineered building will be single source availability. Single source availability, that is, since all the components, all the building components are provided by a single vendor, so the quality of the material will be assured. So all the components will be provided by single vendor, that is single source of availability. So the another advantage is less maintenance. So it has less maintenance cost. Since we are providing very good painting, high quality painting in a steel structure designing, so it requires less maintenance, because when we are providing a high quality paints for these pre-engineered buildings, it will have more durable. So it will consume the less maintenance. So the maintenance cost will be reduced. So these are all some of the advantages of using these pre-engineered buildings. So the main aim or intention of this study is cost effective and also the environmental friendly building construction. So I hope you all understand this concept, that is pre-engineered building. So let us see what are all the agencies which are contributing in this cost effective and environmental friendly building construction in the next session. Okay, thank you.